All right. So this here is the one equation we're going to do today. I know there's another one, but we're going to do this one here. Yep. So this is the only problem we're going to be doing today. We worked with solving radicals the last few days. And at most, we had one radical on either side. We've never seen something like this here, yes? Because we've had one radical on both sides. We've had one radical and had x outside of radicals like we did yesterday. And we solved them that way. This here and the other one, we can solve the exact same way. The main thing is that we don't, if we can avoid having two radicals on the same side, we want to avoid that. Now the other problem on this work, or kind of the note sheet, if you look on the back, we don't have that option because there are 3 of them. So we would split them up 1 and 2. If we had 4, we want 2 and 2. We want to try to keep it as even as possible. But we're still going to do the same things that we did the other day, because once you You're welcome. So here we've got it in as best a situation as we possibly can. We've got 1 on one side, 1 on the other. So we're good. So what we can do, just like we did the other day, is if I square both sides here, because here, if I square the square root of 2x, well, the square root and square would cancel, yes? Because these will cancel, leaving me with just 2x. And that's how we've had it the last few times we worked this, because if I square a square root, they cancel out completely, yes? Because we look at the right-hand side, because I have a square root, I just have the square root and the square, they can cancel out, right? I don't just have the square root anymore, do I? No, we have the square root of x plus 7 minus 1, yes? What this is really saying is I have square root of x plus 7 minus 1 times the square root of x plus 7 minus 1. They will, yes, but we have to multiply all the way through. So let's see what happens. And I'm not going to just completely cancel radicals out as I go. I'm going to write it out completely. So we'll have 2x, because it stays over here, is equal to, we'll have the square root of x plus 7 times the square root of x plus 7. Well, anything times itself, I can just rewrite the square root of x plus 7 squared. So yes, this radical and square will cancel eventually, but I'm going to write it as this here first. Now we're going to have the square root of x plus 7 times negative 1, which is be negative square root of x plus 7. Now we're going to the next one, negative 1 times square root of x plus 7, which will be negative square root of x plus 7. And last but not least, negative 1 times negative 1 would be plus 1. So any questions on anything we've done thus far? Okay. So when we look at this here, well, 2x is still just going to be 2x. Now here, the square root of x plus 7 squared, well, this square root and square will cancel. Leaves us with x plus 7 minus. These square roots are the exact same, yes? So we can combine them. We can use our addition and subtraction and combine those together. So I have a negative and a negative, which would give me 2 of them. Negative 2 plus 7 plus 1. So even with doing that, squaring both sides, and we had to do that whole distributive property, I really only have how many square roots? 1, yes? okay? And I may have mentioned it, I think, on Monday, where sometimes when we were doing our steps, get the radical by itself, put both sides to the nth power, and solve, we might have to run through these steps a few times. This is what I was talking about. Is we started out with having two radicals. We squared both sides. Now we have an equation with one radical. So we have to go back to the top of the steps, yep, and get the radical by itself, or at least close to it. Now I can combine some like terms. Because our 7 and 1, we can combine to get 8. And now we need to move everything, or almost everything, over to the other side. We subtract x from both sides. Which these will simplify out, and this will give us x is equal to minus 2 square root of x plus 7. Minus the 8. I need more room. Which would give us x minus 8 equals negative 2 square root, bless you, to this here. Right. But I really don't want to. Because I would be all for it, especially if we had 2x minus 8, because if we divide by that 2, it's going to give us 1/2 x, because that x and 2 won't divide evenly. So normally we would really want to do that, but let me see. I'm just going to leave it as this here. Because interestingly enough, this will work just fine. But normally we want to really get that radical by itself, because it does help us, especially when coming into if it's equal to just a number. Like if this had been just negative 8 instead of x minus 8, we would have been able to say, okay, it's possibly no solution. But here, I'm just going to leave it. And I'm leaving it because it's going to make the numbers work out a lot nicer than if we divided. So any questions on this here? Well, on the left-hand or the right-hand side, we're going to square this. Well, negative 2 squared, because we can apply it to both, is what? Negative 2 times negative 2. 4. And the radical and the square will cancel out. We don't have any radicals anymore, correct? Yep. We have the other side, x minus 8, because this is really saying x minus 8 times x minus 8. Unfortunately, because we will have a middle term. Because if it was x minus 8 times x plus 8, then that would work, because the difference of perfect squares. But this will end up giving us a middle term. Because we do x times x would give us x squared. X times negative 8 would be negative 8x. Negative 8 times x will be negative 8x. And negative 8 times negative 8 will be plus 64. Well, while we're using distributive property, we might as well multiply the other side. 4 times x will be 4 times 7 is combining like terms. Now this is a good site to see because we don't have any radicals. We don't have anything that needs to be squared. Everything is as simplified as we can get it. And we have a quadratic. So now we can actually start the solving process by moving everything to the same side because we have a quadratic. So we can subtract 4x first. 4x minus 4x on the right-hand side will cancel. On the left-hand side, 16x minus 4x is going to be negative 20x. We have x squared minus 20x. I will move it up here in a second. Plus yep. So once we've moved everything to the same side, we'll get x squared minus 20x plus 36. Any questions on how we got here? And it's taken a bit to get here. So we kind of were somewhat here with this here, somewhat for the most part. Now this is factorable. And we would have minus and minus x and x for this here. Because the third term is positive, so the signs are the same and they match the sign of the middle term, which is negative. It works out that the factors that we want are 2 and, bless you, 2 and 18. Because I worked this one out earlier, and it took me a minute to see 2 and 18, because 36 has a lot of factors. But 2 and 18 will be the two numbers that give us negative 20. And last but not least, we are in the home stretch. Add 2 to both sides, which will tell us x is equal to 2. And here we can add 18 to both sides. So our two solutions for this here are 2 and 18. And that's it. So here we can see that this is a little bit more complicated. Well, it has a lot more steps. We had to repeat this process a few times to get down to the final answer. We had to square both sides, use our distributive properties, then reorganize it, get the one radical by itself, move everything to the other side, do it again, and then we were able to finally get down to this here for 2 and 18. Now, before we call this problem finished, let's go on and check our answers. Let's make sure we got the right answers. We can use the graphing calculator to do this. So what I'm going to do is I'm going to grab the graphing calculator and put in square root of 2x. Well, I got the square root of 2x from the one side of the equation, yes? Now, the other side of the equation was the square root of x minus 7 plus 7. That would have given us a whole different answer, or no answer at all, plus 7. minus 1. So these are our two equations, that's parts of this equation that we set equal to each other, yes? So our solution should be where these cross. So one of our solutions was at 2, yes? Because x is equal to 2. Well, the y values, what these both equal, are actually 2 and 2. So when x is 2, they do have the same value. And the other one we found was at 18, yes? 18 does not give us the same values. It gives us different values, yes? Because it gives us 6 and 4. So what that means is that 18 is an extraneous solution. It does not work. So, erase. And I can show you all this here. So let's look at 18. Because 2 times 18 is equal to the square root of 18 plus 7 minus 1. Because 2 times 18 would be 36, and 18 plus 7 is 25. Well, the square root of 36 is 6. Square root of 25 is, well, 5 minus 1 is 4. These are not the same. So that means 18 is an extraneous solution. So our only real solution for this is 2. And that is it for that one. You all want to see how this one here has worked? No? Okay. Okay. So, you're good. You're perfectly good. I'll work through this one here. If y'all are good with this here, y'all can go on and start working on the assignment. So, right, these here are a little bit interesting in how they work because they work way differently than what we did on any of the others. Now, when we look at this here, because we do have 3 instead of 2, we're still going to do the same process. Because this is as best as we can get it, we're going to go on and square both sides. Now, out of these two here, the right-hand side, where we just have the square root of x minus 4 squared, well, that square root and square will cancel. So on this side here, we're just going to have x minus 4 because these do cancel. And I ran out of room. However, on the other side, we're going to have to multiply it by itself. So we're going to have to actually do that multiplication out. Now here, 2 times square root of x minus 1, or x plus 1. 2 square root of x plus 1 times 2 square root of x plus 1 is really going to be 2 square root of x plus 1 squared. Now 2 square root of x plus 1 times negative square root of 2x. What's interesting with this here is this going to be negative 2 square root. Because the radicals are the exact same index, we can actually multiply what's inside. So what we're going to actually have is 2x times x plus 1 on the inside. And I'm going to write it like this here because it's a little bit easier for us to work with this here than it is to try to think of the fact that it would be 2 square root of x plus 1 times square root of 2x as those two separate things. So we can go on and put them together. Well, we're going to have it again. 2 square root of 2x times x plus 1. And last but not least, negative 2x square root of 2x times negative square root of 2x will be plus square root of 2x squared. And so equal to x minus 4. All right. Now we do need to simplify some of these squares. So like the first one here, 2 square root of x plus 1 squared. Well, the 2 squared would give us 4 times x plus 1, because that square root and square will cancel out with there, and we had to apply it to the 2 as well. Good so far? Now these middle two will combine because they are the same radical. So negative 2 and negative 2 would give us a negative 4 square root. You understand how those put together? Okay, because I'm going to make another step. We're going to do another step as well, as long as you're good. Because these will multiply together, yes? 2x times x is 2x squared. 2x times 1 is going to be plus 2x. Because I'm a little hesitant on doing multiple steps all at once because it gets a little bit confusing. Okay. Now we have the square root of 2x squared. Well, those will cancel, leaving me with plus 2x equals x minus 4. So even though we had 3 square roots, it's still pretty much we're at the same spot we were on the last problem. We are now down to 1 square root. But before we start squaring again, we need to combine like terms and move things to the other side. Because trying to square it like it is now would be a little temperamental, because on the left-hand side we have 1, 2, 3 things that would be squared, or having to multiply by itself. That's going to be massive. So before we do that, I'm going to multiply through by 4. If you give us 4x plus 4 minus 4 square root of 2x squared plus 2x equals x minus 4. X and 4x are like terms, yes? So we can add those together since they're both positive, and 6x plus 4. All right. We have all of our like terms combined. We have it as simplified as we can get. Now we're going to start moving everything to the other side. So we can minus 6x from both sides, which would leave us with 4 minus 4 square root of 2x squared plus 2x equals negative 5x minus 4. Almost done moving everything. We can also subtract 4 from both sides. Okay, so we have the radical by itself. I mean, we could move or divide everything by negative 4, but I don't want to do that because of the 5x. Because 5x and 4 won't simplify to a nice whole number. It ended up being 5/4. but we are able to square both sides of this here. Now, nicely enough, on the left-hand side this time, it will simplify pretty easily, because we can apply the square to both of them. Now, negative 4 squared, well, negative and squared makes it positive. 4 squared, 4 times 4 would give us 16. And the square root and square would cancel, leaving us with 2x squared plus 2x. And that side's the nice side. Now, on the other side, we're actually going to have negative 5x minus 8 times negative 5x minus 8. And oddly enough, we'll see this here in a second, everything on the right-hand side is going to be positive. Well, if we're distributing, we might as well do it all at once because we only have a limited amount of space. Right? You only have a limited amount of space on your paper. So if we distribute the 16, 16 times 2 is going to be 32, and we have x squared. 16 times 2x is going to be plus 32x. So that distributive property is not bad. Now, if we look at the other side, negative 5x times negative 5x. Well, negative 5 times negative 5 is positive 25, and x times x would give us x squared. So it turned out to be positive. Well, negative 5x times negative 8 is going to be plus 40x. Negative 8 times 5x is going to be plus 40x. And lastly, negative 8 times negative 8 is going to be a positive 64. Okay. Well, if we don't have any more radicals, we just have quadratics. Now, I'm going to move everything. We're going to combine some like terms, but I'm going to eventually move everything to the left-hand side. And the reason I want to move it to the left-hand side is because, well, 32x squared and 25x squared, 32 is bigger. So if I move everything to the left, I'll have a positive x squared. Because 36 minus 25 would give us 7. 25 minus 36 would give us negative 7. So I try to keep everything positive. But before we do that, I'm going to combine the two 40s to give us 80. And now we can move everything over. Okay. I'm just seeing how you're doing on space. Let's do this in one move, since you're running a little short, because we're going to move everything over to the other side, yes? Okay, we'll do it in two, so it doesn't look as scrambled. As we know, we're going to move 25x squared. Now, if you want to put a little dashed line to kind of make sure, kind of if you ever, for some reason, decide to look back at this, that there's a split between those two. That we're actually moving everything over. Now, 32x squared minus 25x squared is going to give us 7x squared. 32x minus 80x is going to give us negative 48x is equal to 64, because all this stuff is gone. And lastly, we've got to move the 64 over. I didn't want to do it all in one step because I realized it would be a lot all in there. So the last thing we have to move is the 64. And last but not least, we need to factor this to be able to solve for the values of x. Now, the 64 is negative, so the signs are going to be opposite. One's going to be positive, one's going to be negative. Now, this is kind of just with doing these factorings for so long. I know the middle term is negative, yes? So the bigger of these two multiplication, when we multiply out to get back there, it needs to be negative, yes? So, however 64 works out, I know for sure 7 is going to give us a big number when we multiply, because the other one is going to be 1. So what I'm going to do is I'm going to keep it away from the negative. I'm not going to put it in the same set of parentheses as the negative, because I know when I do the multiplication that 7x is now going to be multiplied by the negative number, making it bigger. And it works out, the factors of 64 that we want are 8 and 8. And this would give us negative 48 if we did check it. Oh, too far. That brings us to the very last step, is solving. First step here is going to be subtract 8, so we get 7x is equal to negative 8. We divide by 7 and get that x is equal to negative 8 sevenths. And over here, which is going to be a little bit easier, we add 8, which shows us x is equal to 8. Now looking back at this here, negative 8 sevenths isn't going to work, partly for two reasons. Because if we look back at the original problem, all of it's gone. 2 times negative 8 sevenths, it's still going to be a negative number. We can't have it inside of a square root. So that one's not going to work. 8 will work for this here, because even if we checked it, 8 plus 1 is 9. 2 times 8 is 16. And 8 minus 4 is 4. Square root of 9 is 3. Square root of 16 is 4. Square root of 4 is 2. 2 times 3 is 6. Minus 4 is 2. And that's it. Questions on that there?